All right, today we are diving into a new AI model called Chronos. And what's so cool about it is that it takes a problem as old as time, literally forecasting the future, and attacks it in a way that's, well, completely new. It's a wild approach that forces us to rethink what numbers even are. So let's get into it.
So here's the big question that's always plagued the world of forecasting. Think about it. If you want to predict stock prices, you build a model. If you want to predict website traffic, you build another totally different model. Energy demand? Yep, a third model. It works, sure, but it's just so inefficient. The holy grail, the dream, has always been this. What if you could have just one model that could do it all?
And that is exactly the problem that Chronos sets out to solve. This whole mess of building custom one-off models for everything, it's a huge bottleneck. It takes time, it takes expertise. So the folks behind Chronos asked a really simple but powerful question. What if we could just skip all that? This really lays out the two worlds, doesn't it? You've got the old way, you get a new data set, you have to spin up a whole new model, tune it, get an expert involved. It's a ton of work. And then there's the Chronos way. The promise here is one single, powerful, pre-trained model that you can just point at any time series and it works right out of the box.
Okay, so how is that even possible, right? It sounds a little like science fiction. Well, the whole trick, the big idea, is a massive shift in perspective. It's about stop thinking of data as just a string of numbers and start thinking of it as a language.
And this is the central idea that makes everything else click into place. The model is designed to learn the language of time series. Think about it this way. We already have models that are amazing at reading a sentence and predicting the next word. So why can't a model read a sequence of numbers and predict the next number? It's the exact same logic, just a different language.
Now here's the clever bit of engineering that makes it all work. It's a technique called regression via classification. That might sound complicated, but the idea is simple. Instead of trying to predict a super precise number, like 105.73, the model just predicts which bucket or bin the next number is going to fall into. It's a classification problem. It's like, is the next number small, medium, or large? And that is something language models are absolutely fantastic at.
So we're turning numbers into a language, but how do you actually do that? How do you turn a raw number into a word that a language model can understand? Let's walk through exactly how it's done. It's actually a pretty elegant three-step process. First up, you scale the data. This is super important because you might have one time series that goes from 0 to 1 and another that goes from 1,000 to 1,000,000. Scaling puts them all on a level playing field. Then you quantize. This is the magic step. Each of those scaled numbers gets sorted into one of those bins we just talked about. It gets turned into a token, basically a word. And once you have a sentence of these tokens, the last step is simple. You predict the next one using a totally standard language model. And get this, the entire vocabulary that Chronos uses to describe all these different numbers is just 4,096 tokens. That's it. Most of those are the bins for the values, and there are a couple of special ones for technical stuff like padding. When you think about it, that is a surprisingly small dictionary to describe pretty much any numerical pattern you can throw at it. Okay, but wait a second. Anyone who knows anything about language models knows they are hungry. They need absolutely massive amounts of data to learn. So where on earth do you get enough time series data from all different domains to properly train a model like this? Well, the answer is, if you can't find the data, you make it. This is called data augmentation. Chronos uses two really clever tricks here. The first is TS mix-up, which is kind of like being a DJ for data. It takes a few real-world time series and mixes their patterns together to create brand new, realistic-looking examples. The second one is called kernel synth, and this one generates totally new synthetic data from the ground up, using basic mathematical patterns like trends and seasonality. And the final training recipe? It was mostly the mixed-up real data, with a little bit of the pure synthetic stuff thrown in. All right, so the theory is fascinating. The engineering is super clever. But here's the million-dollar question. Does any of this actually work? Let's look at the numbers and see how Chronos stacks up in the real world. First up, let's look at how it performs on data that's kind of like what it was trained on. And the results are really, really good. Now, on this chart, we're looking at error, so a lower bar is better. And you can see pretty clearly the large Chronos model is the hands-down winner. It's beating out a bunch of other strong, established models. But honestly, this next one is the test that really matters. This is zero-shot performance. That means we're throwing datasets at Chronos that it has never seen before.
This is the ultimate test of a general-purpose forecaster. And look at that. Even with zero specific training for these tasks, it's right up there, super competitive with models that were custom-built for them. This is what we wanted to see.
And here's the kicker. You take that really good zero-shot performance, you add just a tiny bit of fine-tuning for the new data set, and boom, Chronos jumps to the #1 spot. It goes from being great to being the best. Okay, so it's established. The thing works, and it works well. So let's switch gears and talk about the practical side of things. What did the researchers learn about what makes it tick? And how would you actually go about using this in a real-world project? First question, and it's a big one for any AI model these days. Does size matter? And the answer is a resounding yes. Bigger is definitely better here. The data shows a clear, consistent improvement in performance as the model gets bigger, all the way from a 20 million parameter model up to the big 710 million parameter one. And remember that data recipe we talked about? Well, it turns out there's a definite sweet spot. The best results came from a mix of about 90% of that blended, remixed real-world data and just 10% of the purely synthetic stuff. It seems like that little dash of completely artificial data gives the model a really significant performance boost.
Now, of course, no model is perfect, and the creators are really open about Chronos' limitations. Because it's sorting numbers into a fixed number of bins, it can have trouble if a value is way outside the range it expects, or it can lose a bit of precision on series that have a gigantic scale. It can also sometimes lowball a really strong trend if it doesn't see enough historical data, but, and this is the important part, for every one of these problems, they offer a pretty straightforward practical fix.
So what this all adds up to is a really clear playbook for anyone who wants to use Chronos. The advice is basically start with one of the smaller pre-trained models for a good balance of speed and accuracy. If you're close but need that extra edge, just fine-tune it a little bit. If your data is growing exponentially, do a simple log transform first. And if you're dealing with long-term patterns, just feed it a longer history. It's a super practical set of instructions. So when you step back and look at the big picture, Chronos is more than just a new model. By completely reframing the problem, it proved that this idea of a universal forecaster isn't just some far-off dream anymore. It's here, and it works. The model truly learned the language of time series. And that leaves us with a really exciting open-ended question. What other hidden languages are just sitting there in our data, waiting for us to figure out how to listen?